This is Matsuura speaking from Japan. I'm sorry, I cannot join the meeting in Vietnam. But instead, my friends, Dr. Chris, will give a presentation of our research. This time, we are going to talk about the analysis of agricultural land losses using DMSP nighttime lights. And we used nocturnal light data collected by multiple satellites in 1992, 2000, and 2008 are used to analyze agricultural land losses. Overlaying DMSP datasets on vegetation datasets, we attempt to calculate agricultural land losses by using spatial information for 3 periods. That means if the lights exist, those areas might be changed from agriculture area to the land factory areas or other land areas. That's a simple methodology. And this is a correlation between the income, $1,000 US, and the light volume are very well correlated. In case of year, this data set is in year 2002. And demand for land. Economic development maybe requires more roads or factory areas, or the agricultural land might be changed to the factory areas. And this time we used DMSP datasets to estimate the impacts of human activities. And also we compare with the datasets provided by the Food and Agriculture Organization statistical datasets. And this, at first, we reclassified the nighttime datasets. And this is in case of 2000, 1992, and 2008. And this is a place where the light exists or the light is not exist. If the light exists, those area is defined as line volume 1. And multiplying, we also multiplying these declassified data sets. In case of 1992 data, we used it as 1. And in case of year 2000, we multiplied 10 for the data sets in 2000 and multiplied hundreds for the data sets in 2008. So this is a case of around Shanghai. This is in Japan. This is Japan, and the Shanghai regions, and this is colors. And that means the obtained data sets for western part of Japan and the eastern part of China. So this is vegetation data sets provided by the Japanese Geographical Survey Institute in Japan. And they have almost 20 legends such as broadleaf evergreen forest or broadleaf deciduous forest or those kind of things. And in this data sets, we used cropland and paddy field, and cropland and other vegetation mosaic. We used these data sets. And the 3 legends, we defined, reclassified these 3 legends as value 1. Making use of GIS, ArcGIS softwares. And analysis, assuming that nighttime lights on agricultural land express agricultural land losses, we multiply the nighttime data sets by the agricultural lands. And subsequently, we can estimate the change of agricultural land losses in 1992, 2003, 2008. ArcGIS software has a zonal statistics functions, so we use the zonal statistics tools to estimate the number of cells in each countries. And then we compare with statistical data sets. The vegetation values for 1992 is obtained using the following formula: total -1, -11, 111. For 2000, using the following formula, total cell numbers minus 10, minus 11, and minus 110 and 111. And for 2008, total cell numbers minus hundreds and 101 and 110 and 111. So we could define comparing statistical data sets with the values. X-axis shows the statistical values, and Y-axis shows the graded value for 1992, 2000, and 2008 in case of cropland. And this is also the paddy field change. Paddy field change is also X-axis are statistical values, and Y-axis is the graded values, paddy field. And also cropland as a vegetation change, this X-axis is statistical values and Y-axis graded value in three times. So the conclusions. Still this analysis is in progress. Overlaying global scale nighttime light data for 1992, 2000, and 2008 on the vegetation maps, we tried to calculate agricultural land losses. The results were compared with country-based statistical values. The areas of crop and crop vegetation change drastically year by year. According to farmers, it is important to plant crops on the basis of producer prices, so the change does not appear as big with respect to rice. So this is the results. So for future work, for future research, we should consider the coherence of association between graded vegetation and foul stat more precisely in spatial distribution or the major crop producing countries, those kind of areas, we should think of that. But we need to consider a newly developed agriculture area for type and bush in Brazil. We also take into account the intensity of lights. So in this case, we don't take into account the intensity of lights. We just use where light exists or light does not exist. So we should take into account the intensity of lights. Also, the possibilities of using DMSP datasets on agricultural land losses are investigated. So acknowledge, thank you. This nighttime image and data processing was performed by the NOAA's National Geophysical Data Centers. The DMSP data were collected by the U.S. Air Force Weather Agency. Thank you for their collaborations. So this is the reference. Thank you for your attention. Let us keep in touch with